Now that we've spent some time learning this and practicing some problems, can we start to put together the concepts we've learned? Let's work some examples. First up, what is an isotope? Can we just define what an isotope is? Well, let's think about it. If I have an atom of some element, and let's say I've got a second atom of the exact same element, the difference between these two, let's just say I've got, it's element A, which is not an element intentionally. uh, I'm not picking a real element here, but let's just say I've got an element. I'm labeling it A as a placeholder. The difference between these is that the two atoms are atoms of the same element. But I just said difference. Now I'm saying same. They are the same element, but the atoms themselves differ in the number of neutrons in their nucleus. What that does is it causes the atoms to have a different mass than one another because they have a different number of neutrons. And remember, neutrons and protons each weigh about 1 AMU, whereas electrons are 1/2000. So, for example, if I had hydrogen, I know hydrogen has one proton and one electron. One of the isotopes of hydrogen has one neutron. One of the isotopes has two neutrons. There is three isotopes. We talked about that in class. This is just two of them. These will weigh different things. This overall will weigh 2 AMU, whereas this will weigh 3 AMU. Same element, same behavior. They have the same number of protons, which makes it the same element. They have the same number of electrons. They're both neutrally charged, neutral species right now. They're not charged species, but they have a different number of neutrons, and that's what makes an isotope. Question two, an atom represented by 106 tin has how many neutrons, protons, and electrons? Well, we've got Sn, which we know is tin. Why do I care? Because I need to know how many protons this thing has, and I'm going to look at the periodic table and find it. I know tin, I look it up, and tin has an atomic number equal to 50. That means the number of protons is 50. As written, this species does not have a charge on it. Remember, if I had a charge, I would put the charge right up on top here. Above, it would be written like 106 SN, and then let's say it was a +2 charge, I would write 2 plus right up there. Okay, 10 does a 2 plus charge. I don't have anything written there, therefore my number of electrons and my number of protons are equal. The last piece I need here is my number of neutrons. Your mass number equals your protons plus your neutrons. And this number here is your mass number. So that 106 is equal to the number of protons plus the number of neutrons in this in the atom of this species, which means you have 56 neutrons present. Let's work the next example. An atom represented by 18O2 minus has how many neutrons, protons, and electrons? Well, I know O is oxygen. And when I look at my periodic table, I see that oxygen has an atomic number of 8, which means my protons here are equal to 8. But notice this one does have that charge. I've got that 2 negative charge up there. What that means is this is an ion. It's specifically an anion because it is negatively charged. That means that it has more, it's gained electrons. Anions have gained electrons, and it's gained enough electrons to cause this originally atom, which is now a charged ion, to have a -2 charge. The only way to do that is for it to now have 10 electrons. And lastly, my mass number listed here is 18. I know that mass number is equal to the number of neutrons plus number of protons in my system, so my number of neutrons has to be 10. Number 4, an atom represented by 53 Fe3 has how many neutrons, protons, and electrons? So you guys should be a pro at this by now. If I look at this, I know Fe is iron. I look at iron on the table, and I see the atomic number of iron is 26. So now I know I have 26 protons. It also shows me here that this specific iron I'm looking at is an ion with a 3 plus charge. Now remember, you cannot gain or lose protons. If you change the number of protons you have changed the species itself. So you're only gaining and losing electrons. In order to cause that 3 plus charge, I need to lose 3 electrons from the original neutral atom. So my number of electrons will be 23. And then I have a mass number here of 53. I know my mass number is equal to the number of protons plus my number of electrons. So my number of neutrons must be 27. What's this next page got in store for us? Let's see. First up, what is an ion? What does an ion mean? An ion is just any charged particle. It means your number of protons is not equal to the number of electrons. It doesn't specify which way it is here. It doesn't specify if it's positive or negative charged. It just says what is an ion. And an ion is just that. It's a charged particle where the number of protons and the number of electrons are not equal. What is a cation? A cation is a positively. I apologize. I've got a cat on my lap while I'm trying to write this. So cations are positively charged. To form that, it means it lost electrons. Maybe 1, maybe 2, maybe 4. Okay, different species can lose different numbers of electrons, but it lost electrons. So the number of protons here is greater than the number of electrons that I have present. And what is an anion? An anion is a negatively charged species. So again, I cannot gain or lose protons. If I change the number of protons, I have absolutely changed the species I have present. I can, however, change the number of electrons I have. And so to cause a negatively charged particle, I gained electrons. Maybe 1, maybe 2, maybe 3, maybe 4, who knows? But I've gained electrons. So here, my number of protons is less than my number of electrons. Okay? And we have one more example in this section. What species is represented by the following information? I've got the number of protons, the number of neutrons, and the number of electrons listed. Protons tells me the atomic number. That's nice and convenient. That tells me I have silver. Neutrons will just tell me the mass number with the protons. So My number of protons plus my number of neutrons equals 109. So I know I have isotope 109. The electrons here, though, notice that this is one lower than the number of protons. So I lost an electron here, which means I have an ion. Specifically, I have a cation because it is positively charged. So if I was to write, I do know the species itself is a silver ion, but if I want to write out in the correct format, I'm going to write silver, I'm going to write 109 for its mass number, and I'm going to write plus for its charge.